Presentation, we have Alex Bradbury. He's a PhD student at the University of Cambridge Computer Laboratory, and he acts as a lead software developer for the Raspberry Pi Foundation. In that role, he leads and coordinates software development efforts for the device, including production and distribution of the Foundation's official Linux SD card images. When studying for his PhD, Alex works with the LLVM and Clang as part of his research in compilation techniques for a novel many-core architecture. So over to you, Alex. Thank you, and sorry about the delay.
Right, so thanks very much for that introduction, and also thank you for the LCA organisers for making it possible for me to be here. So this talk is going to be rather more technically oriented than many of the previous Raspberry Pi talks I've given. Yes, the outline isn't all that relevant, but I'll start off with a little bit of an overview of the educational aims and a bit of an introduction to Raspberry Pi, though I'm sure that most of you are pretty familiar. Could I just have a show of hands, actually, how many people actually own a Raspberry Pi? Ooh, very pleasing. All right, those of you who didn't put your hand up, I'll be talking to you very sternly afterwards. We're charity. So the Raspberry Pi Foundation is a UK registered charity, so it was set up, well, we're actually incorporated a few years ago, but we only really hit the public sphere about a year and a half ago. The unit went on sale at the end of February last year. We're approaching 1 million shipped, and essentially we produce a low-cost credit card-sized circuit board, which is a full Linux computer. And the stated aim of doing this is in order to act as a tool which can be used in education to improve the teaching of computer science in the UK and worldwide. But of course, as I've been discussing with many of you so far at this conference, there are many other applications. So in case you're not familiar with basic I/O, we have up at the top there we have GPIO pins for hooking it up to various sensors, external devices, SPI, I2C, I2S, composite output for old-style televisions, or preferred, obviously, HDMI output, as well as Ethernet and 2 USB ports on the Model B. The picture I'm showing you here, this is actually the latest revision, which was updated a number of months ago. So when we first launched, it was 256 megabytes of RAM of a package on top of the Broadcom chip, which gives our CPU and GPU. But we've upgraded that to 512 megs, and perhaps the more pleasing, well, even in a way, more pleasing upgrade is that it's now made in the UK, which is we're all very pleased about. We could move all the manufacture, well, a substantial portion of the manufacture. I think there are some which are still coming out of China to Pencoed in Wales. Yes, and it's a ARM1176 processor running at 700 megahertz, which I'll discuss a bit more when we come to discuss the various issues we've had with optimizing the various Linux distributions to run on our platform. Now, the basic motivation is one which I don't think I need to take too much time to try and get you to see my point of view or persuade you in any way. I imagine that I'm preaching to the choir, essentially. The problem is that there's a shortage of computer science talent in the UK and worldwide, and on the one hand, it's quite helpful for those of us who are entering the workforce, because we go to careers events and there are more companies than there are people looking for jobs, which is always nice, but it has negative effects as well for companies looking to hire and potentially the economy. And the argument is often made purely in terms of that aim in order to produce more people who can enter the workforce working with CS, but I think the stronger argument is more fundamental than that, which is that just like we teach children biology, physics, and chemistry so that they can understand the physical world around them, we also need to teach children the basics of computing so they can understand the digital world in which they now inhabit. It's sort of tragic that children have missed out on this, as Bedell said in his keynote. A lot of education is focused on applications of computers rather than concepts, and the sort of applications are often PowerPoint or Excel, when there's all sorts of exciting things, as we know, that children can start to learn how to do when they get the concept that actually a computer isn't a black box where you go into the Apple store and you buy it, and you can perhaps download a few apps onto it, but otherwise it does what it does. But actually, if you have a problem, you can come up with a solution, code it up, and solve it yourself. Now, I should say that we are only one of a number of different organisations in the UK who've been working on this problem, and many of them have been working on it for quite a lot longer. And I assume that there are some corresponding organisations in Australia and New Zealand. It would actually be helpful if anybody who's involved in that could post a summary on the LCA chat mailing list, perhaps giving pointers where people can, who they should talk to if anybody in this talk is interested in helping out in Australia. So with our launch so far, as I mentioned, it's at the end of February we went for sale. As many of you will be aware, this was a slightly problematic launch in that we go for sale, we immediately managed to crash the websites of Farnell and RS, who are the largest electronics distributors in the UK. We did warn them, but it wasn't quite enough. And there were some supply problems for a little while, but which have now been resolved. In fact, I'm finding it very enjoyable to be at a conference where for once people aren't coming up to me all the time asking me where their pie is. There's only been one or two of them so far, and they're mostly people who have bought by third-party sellers. So it's been part of the aim. It's been expected that up to this point, most of the people who, or up to a few months ago perhaps, most of the people who have bought into Raspberry Pi have been people like ourselves sitting in this audience, hackers, makers, geeks, programmers who see it as a cheap, fun toy. And perhaps, it's been known that there's relatively small push from that. So we now have a full-time hire who was just announced with the announcement yesterday from Google, who've just announced something. It's been reported as $1 million package, including 15,000 Raspberry Pi. But of course, getting it onto the curriculum is one way to get it into the hands of children. Perhaps in the more immediately, we've had lots of success with after-school clubs, or particularly with Code Club and Coder Dojo, both of which are organisations who arrange these. I forget which one it is, either Coder Dojo or Code Club. One of them recently posted a blog post about their London meetups, and they managed to get a 40% female, 60% male ratio, which was it's not 50-50, but it's substantially better than you might expect if you look at the average makeup of a computer science university course. Now, there are just a couple of pieces of software I wanted to highlight here before I go into more about more of the technical details. So obviously, Python is pushed as a first programming language, though it is just a Linux box. It runs Debian, or a derivative thereof. You can install whatever you want. If you really think that Haskell's the best way to introduce your kids to programming, then by all means you can do that. Now, Scratch, I hope many of you are familiar with Scratch. This is a project from MIT, which it uses Smalltalk as the implementation language, which has been somewhat problematic for us when it comes to optimizing it, because there seems to be a vanishingly small number of people who are actually working in Smalltalk. So if anybody is a Smalltalk expert who is just raring to dig in there and sort out the various performance problems in the code, then that would be incredibly helpful. We have actually looked at benchmarking it. There were originally some bottlenecks in terms of the actual drawing routines, but a substantial portion of it does seem to be in the Smalltalk source. We've had a few community patches which do things like reduce the frequency of updating displays of the displaying updates on the left-hand side, which have given good results, but there's probably much more that can be done. And if you're not familiar with it, how it works is that it's like a jigsaw puzzle. You choose your building blocks on the left-hand side here. You build a program by dragging them, slotting them together. The idea being that it's a visual introduction to programming, so that children don't need to be introduced to the complexities of syntax errors and things like that just to get started. So with this sort of system, it's very trivial to get a simple game which does something interesting. And here we have the sprites, each of which has a set of scripts associated with it, and the display up at the top, which is showing you the game. If you hit go, then it runs a simple program whereby it the large fish will move towards the mouse pointer, and if it intersects with a small fish, then it will eat it, and that small fish will disappear. And it's very easy to get kids up and started with this. We had I think he was a 7-year-old. He came into the computer lab for some filming, and we hadn't really planned what Scratch project to get him started with, but we just told him to get on with whatever he wanted. So he decided to come up with he had a stage, he had a man dancing, and he asked whether you like tuna, and if you say yes, then he continues dancing. If you say no, then he stops dancing. So it's a really easy way for children to come up with stories, games, whatever, do something creative. Now, the next big thing which is coming is Minecraft Pi Edition. So many of you, I assume, are familiar with Minecraft. It's a 3D virtual world which consists of a large number of blocks, and it is insanely popular with children. I mean, I've been shocked at the number of children who've come up to me and have asked me, is Minecraft available on the Raspberry Pi? Does Notch know about the Raspberry Pi? Does Notch like the Raspberry Pi? He's like some sort of god to them. But the difference of the Minecraft Pi Edition versus Desktop Edition is that it's derived from the Android code base, and also has a scripting interface, so you can open up a socket to it and actually interact. You can modify the world programmatically from the language of your choice, though Python would be the suggested version, the suggested language to work with. And hopefully this will inspire kids to get programming to sort of perhaps first of all just to automate some of the more tedious tasks of the Minecraft world, but you could imagine doing more advanced things like building a game within the Minecraft world, simply using the Minecraft interface as a form of visualization. Maybe building a Pac-Man or Snake game within Minecraft, for instance. And the final software project I just wanted to plug was SmartSim, which is included on our standard SD card image, which was written by so he just finished his computing A-level, which is the UK's qualification before you go to university. And he's done like a 400-page insane report about it. It's written in Vala, and it's a digital circuit simulator, which is totally amazing. He won one of our programming competitions we run, and it's definitely worth a look. So there's the OCR thing coming up, where they'll be working on developing more materials. All sorts of teachers who are really interested in getting the Pi into their schools. I mean, I said that there's this problem with ICT teaching, but it's not fair to think that that's due to teachers. Many or most of the ICT teachers we speak to are motivated. They do care about what they teach their children, and they are very interested in bringing in products like Raspberry Pi or anything else which starts to introduce programming concepts. They totally understand that it's important. So a couple I wanted to mention were, last summer we had Alex Chadwick do a Build Your Own Operating System course, which is a full introduction to ARM assembly programming. So it's called Build Your Own Operating System, but it's more like bare metal programming on a Raspberry Pi at this stage, as it gets you up to a point from you have the Raspberry Pi bootloader, now you have to write the ARM code to do something interesting with that. So he talks you through what ARM assembler you need to write to get something on the screen, initially to flash the LED, then to get something on the screen. Plus the other cool thing he did was write a very minimal USB driver, just enough to get HID devices working, so mouse and keyboard, which is pretty useful for anybody else who's doing very minimal operating systems, because writing your own USB driver isn't particularly fun, as it's very fiddly, whereas you might want to focus more on doing actual cool stuff. Sonic Pi is the other one which I wanted to mention. We've been developing we've got a research assistant who's been working on this for a couple of months at Cambridge. He's really into generative music created from programming languages. So it uses Super Collider as a synthesizer, has a user interface which basically gives you an interface where you can program in, say, play note 15, sleep. It has a whole bunch of other functions, and of course all the standard control constructs of your language, currently using Python. And we've done about, I think So it's being trialled with a teacher called Carrie-Anne Philbin in East London, and the feedback we've got so far is really, really positive in that it's the motivation is that if we use something which is interactive in order to get children to programming, it may appeal to children who otherwise may not be as motivated. So there's things like robotics where you have something which interfaces with the real world, but it's also nice if you have something which makes a sound, or it's very easy to draw something on a screen. Whereas, because basically I think that many of us would have been or were very happy with print hello world when it displays on the screen, and we were overjoyed, but some children just don't really see the point. They see this as more interesting, and they've had really good results just sitting down there playing around, making coolish music, and then modifying the code to make it somewhat better. Right, now the Raspberry Pi software stack is, well, first of all, Raspberry Pi software stack is whatever you want it to be, in the sense that there's an SD card, it's pretty easy to port whatever operating system you want to for it, and there's no requirement that everybody runs the exact same operating system or the same Linux distro. That said, we push a Debian-based derivative called Raspbian as our standard SD card image. Now, Raspbian is actually a full recompile of the Debian package archive, which is, well, if you're familiar with the Debian build process, this is a pretty impressive feat of work. In that, when they first started off, I thought it was very nice of them, very charming that they were so motivated to get going. But I questioned whether they'd actually have a tenacity to pull it off. But it's Mike Thompson and Peter Green. Mike Thompson, he bought something like $1,000 of ARM build hardware before he even got his hands on a Raspberry Pi, just because that he saw that optimizing specifically for the ARM processor, for the ARM chip we have, could be very useful. Set up this build farm and managed to hack together the Debian build scripts until it kind of worked, and then iterated from there. And I should say this is actually something which I personally would like to see improve. I mean, it is very difficult to, as far as I can see, to reproduce a Debian build environment outside of Debian.org. It's not very well documented. It's sort of hacked together with scripts, which is all very nice, but I think it would benefit a lot of people if it were easier to do this sort of rebuilding task. And there were some very interesting Google Summer of Code projects last summer looking at the bootstrapping problem, which was actually easier in this case because the Raspbian guys took the Debian port to using the hard floating point ABI, whereby you pass floating point variables on FP registers, and they did it on ARMv7 boards, because the problem with the standard Debian ARMHF port is that it targets ARMv7, whereas we only have ARMv6, and they were able to just use ARMv7 development boards and replace the packages as they went. In terms of desktop environment, we're currently using LXDE, Midori for the browser. All of these things, if you have a preferred technology and you're absolutely convinced that it could do substantially better, please prove it, make an SD card image, show off it. But I think the Raspberry Pi in particular is a really good platform for showing off technologies that may not have much uptake in the standard Linux desktop. It has, due to the fact that it's relatively low powered, so the trade-offs are different versus what people want to use on a desktop. And also it's very easy to distribute SD card images, people to write them and just see what works for them. We've also introduced a store for people to upload applications, tutorials, media files, which the majority of them are free right now, but people can upload paid applications if they want to. The motivation here being that at least Evan believes strongly that a large number of entrepreneurship may inspire people. If they're not inspired by submitting GPL code and all BSD and MIT stuff and all holding hands with the rest of the world, they might like cold hard cash and the idea of making lots of money by producing a game and uploading it and selling it to other people. So our story of performance since launch, I hope that if you've been with us since we first launched, I think you'll have seen a pretty major improvement in performance since then. Some of it was just from moving to Wheezy, the newer packages seemed to have various miscellaneous performance improvements. Raspbian, which I mentioned, was was our next big performance boost. We've also introduced dynamic overclocking. We did support overclocking previously, but this would potentially void your warranty. So it's just a CPU frequency scaler, which you can set it to maximum overclock. Most units can do 1 gigahertz on the CPU, plus you can overclock you can overclock one of the core clocks on the BCM2835 SoC, which helps with the L2 latency and memory latency, and overclock the SD-RAM itself. Also, USB interrupts. I'll be saying a little bit more about USB in a second, but there were so the USB the initial USB drive implementation would be generating 8,000 interrupts per second constantly. So Gordon has got an FIQ handler to handle the majority of those, and it's substantially improved. We've also done, or had community members doing work on targeted optimizations, such as looking at the ARM libc, the ARM memcopy implementation in libc, and tweaking it for our architecture and our memory and our memory subsystem. Also a bunch of bug fixes. Perhaps most embarrassingly, we had the SD card clocked to some rather silly rate. So initially it was a base clock of 75 megahertz, which isn't, you want to start from 100 megahertz or 50 megahertz really for SD cards, as your target clock is 50 or 25. And there was a division by 2, there was an extra division by 2, which led to substantially impaired SD card performance. So someone submitted a one-line patch which made it way, way better, and we liked it. Now, so there are a whole range of operating systems which currently run on the device. Most people are running Linux. There have been Android ports by the community, and we've shown an internal Broadcom version of Android running. FreeBSD has released now. I should have had NetBSD on the list also. Plan 9 has a pretty complete release, and there's also RISC-OS, but that's not they're obviously not using a full free software license, so it's maybe of limited interest to some of you. Now, yes, so in terms of distributions, we've had Debian has been our main one, but it's also been very useful to or interesting to see how other distributions have tried to compete. So as always, there's this little argument between which distribution is better, and when the Raspbian guys came out with their ARMHF image, a few months later the Arch guys came up with a hard FP rebuild of Arch. So we're hoping to see that continue to sort of improve the whole environment. Now, regarding USB, this is a quote from Greg KH on the Linux RPi kernel mailing list about the problems with the USB controller. So the USB controller, it's a third-party piece of IP licensed and inserted onto the BCM2835 chip that SoC that we use. And yeah, I couldn't comment on the actual hardware implementation, but there have certainly been a large number of bugs with the software implementation. It's had a long history of people trying to get some version of it upstreamed. Like about 2 years ago, APM tried to get a version upstreamed, and they got to version 15, and then they sort of gave up because they weren't getting anywhere. Plus, basically, the issue was that it's almost always used only in device mode. So like in your mobile phone, and you plug it into your computer, and it appears as USB mass storage or whatever. And so the host mode part of the drive has been sort of neglected and not heavily stress tested. Certainly not having hundreds of thousands of people plugging in whatever devices they have lying around. But since then we have had a lot of fixes on improving that. We've actually had, so there are a number of, if you look through the commit logs for a USB drive, you'll basically find lots of cases of really horrible, trivial memory corruption, it doing really stupid brain dead things, but which were quite hard to spot. But they've been fixed. We've had a few community contributions which have also been very helpful there. There were the interrupt reduction things that I mentioned earlier. And perhaps interestingly, in terms of getting this upstream in the Linux kernel, so if we take the position that the existing very large Synopsys driver is not a good base to get it upstream, there's now a FreeBSD USB implementation, which is fairly complete. I think they did have some issues with mouse and keyboard for a while because the split USB 1.1 transactions tend to be fiddly, but I think those are fixed now. And also Plan 9, which is Richard Miller wrote, and it's currently under the Lucent public license, but I think he's pretty happy to release it MIT or BSD. Plus, in fact, a couple of weeks ago, someone tried another patch set for getting host mode support for the DWC OTG USB chip that we use. And if you're interested in any of the Linux kernel, in getting anything upstreamed or hacking on the kernel for Pi, then the Linux RPi kernel mailing list is what you want to look at. If you just Google it, you'll find it. It's hosted on list.infradead.org. Now, on the issue of upstreaming in general, we're hoping to continue to minimize our difference between the upstream kernel from where we are right now. Currently, the big blocker is USB. Stephen Warren has done lots of work, or he's been continuing to work through the various base devices. I think he's got basic support committed, and he's getting there with the SD card controller. Beyond that, there's then obviously USB, and as I'll come on to the messaging layer between the video core GPU and the ARM side code. It's something which perhaps hasn't had that much effort put into it so far, due to, from the Raspberry Pi Foundation itself, due to the fact that up to now we've been purely development effort. There haven't been many people who've been digging in who have kernel submission experience, plus due to the fact that a lot of what it wasn't beneficial to us to branch from the Broadcom kernel tree, which obviously was structured not to be upstreamed, just due to the fact that it was structured to work well for them, not necessarily to be upstreamed and to match whatever kernel requirements there are. But we're hopeful that we can improve on that in the coming months. Now we have some paid employees, and hopefully it won't be too long before you can git clone a standard Linux kernel and compile it and run it on your system with full support for all the onboard hardware. So regarding the graphics stack, we had an announcement a few months ago that all the user space, or in fact, all the user space code would be open sourced, which was that was a part which was previously not FOSS. So the current situation is everything which runs on the ARM is free and open source software. So that means that the kernel driver, as it always has been, is GPLs, and your libgles, libopenmax, libopenvg, those are all released under a BSD license. Now, this does have some practical benefits in that it makes it very easy to port these to FreeBSD, to RISC-OS, or indeed to do things like recompile for different ABI. For those who remember, I understand it was quite difficult, or it took some time to get some of the vendors to cough up ARMHF binaries in the early days of that port. However, due to the design of the split between the video core firmware and the ARM side code, this is a relatively high-level API. So it has some quite fiddly buffer management stuff in there, but otherwise, when it comes to each of your GLES calls are roughly sending command stream to the video core chip, and that firmware is a closed piece of software. Now, yeah, it's a tricky one. It would obviously be, I can see it would be much nicer. It would be nicer if this firmware was also fully open, but as we all know, the line between firmware and hardware is quite difficult. I see it as quite a grey issue. Like if you've seen all the hassle about So for instance, right now, if we were to make it so our firmware was non-modifiable, loaded from NAND, we'd be totally FSF, RMS compliant, fully open, free hardware. So it's a bit fiddly. And certainly if one of the other vendors were to fully open their user space code, that would include low-level register descriptions of their architecture, which would be a step above what we currently have with the Pi. But anyway, the comment here is that now that we actually have a fully open source user space, and that the messaging layer to support communication between the user space and firmware is no longer only there to support proprietary user space, Presumably we can now get it merged, but I think that has been, it's been a little bit controversial. If people can point to examples of similar mechanisms which are in there, that would be very useful. I should say it's not just used for it's not just used for 3D graphics. The messaging systems is used for getting basic information about the Pi that it's running on, such as serial number, the amount of memory you have, the memory allocation, and also basic frame buffer information, and for our ELSA implementation. Now, if you are interested in a more free and open GPU, then totally unrelated to any work of the Raspberry Pi Foundation, there's been some pretty interesting efforts to reverse engineer the Video Core 4. If you look at that GitHub link, you'll find you'll find in the README an impressive list of they've done an impressive amount of research, dug up basically every single patent which Broadcom ever filed regarding a Video Core, worked backwards from that, also did lots of analysis of the binaries, and have now got a pretty decent description of the Video Core architecture, and now have the ability to upload and execute Video Core kernels, which one of the community guys who's been looking at optimizing our Xorg implementation has been looking at. Well, he started to use that to try and upload those kernels and have certain operations run on one of the Video Core CPUs. Now, actually a number of these are almost released. I think I'm the main blocker now. I'm just getting just uploading the image which has most of them supported. So we've moved to the 3.6 kernel, and Dom Cobley's implemented the CMA contiguous memory allocator support, which we probably won't enable that by default because we seem to have a few people seem to be able to run into a few issues every now and again, but this allows for fully dynamic memory split. Right now, you have to choose the allocation of memory between the CPU and the GPU at boot time. At least you modify a config file which indicates how much to have for the CPU, how much for GPU. With CMA, we can have that switch between. We can have that switch. We can have that change at runtime depending on what the user's running. We've had some work on optimizing Pixman, which is the rendering library, which is used by Cairo and Xorg and a whole bunch of other stuff. Specifically, optimized ARM code for various operations there. So again, we're running an ARM v6. Linaro have previously submitted a bunch of stuff for ARM v7 using the Neon instructions, which we don't have. So we've had a very talented guy looking through this, and those patches are published to the Pixman mailing list in December. It should hopefully be merged soon, and we should have a version of Pixman compiled to those optimizations in the next SD card image release in the next few days. Now, in terms of Xorg, so optimizing Xorg has been it is very difficult due to the fact that we can look at optimizing Pixman, and it would be ideal if we could offload as much as possible to the GPU, given that with the Raspberry Pi's architecture, we have a very powerful GPU, which is up there with the current generation SoCs in mobile phones, whereas the CPU is comparatively perhaps a little bit weedy. It's, ARM v6 is a generation or two ago. Now, in practice, it's very, very difficult to usefully offload the work to a GPU as far as we've been able to investigate. The efforts to implement Cairo or other rasterization libraries with a GL backend have all had mixed success at best from everybody I've spoken to. Plus, the way that and then partially this is due to the fact that the way these APIs are used, you often end up by submitting a small amount of work, and then very quickly you ask for a result back. And if you have a unidirectional stream of commands, and then you ask for the composed result of that at every single frame, then that works very well with the implementation of GPU. But if you're asking for thousands of little operations, then the latency is going to totally kill you, and you get a horrible performance slowdown. We did have some work done by Collabora on implementing Wayland support on Raspberry Pi, which is actually merged upstream again. So if you have a look at the Wayland website, you'll actually have instructions on downloading, compiling Wayland, and it actually makes use of, rather than just the GLES backend, it uses the dedicated compositing hardware, which the Broadcom chip has. It's not a fully, there are still some issues with it, but it's probably worth a play if you're interested in that. Other general stuff which will be happening in the future is, well, potentially there's a first boot experience and making it a bit easier for kids who are plugging in their Pi for the first time, and definitely things like deploying and managing it in a classroom. If anybody's interested in that, for instance, if you're a sysadmin and you want to help your school to deploy and manage a number of Raspberry Pis and write up your experiences, like provide some sort of a blueprint for how you get this done, I think that would be particularly helpful, as a lot of teachers are rejoicing at the fact that they don't have to deal with network admins who won't let them install Scratch on their computers, won't let them install Python, except now they're left with a suite of computers which they have to manage themselves, and they don't really know, what to do, how to handle things like taking backups of children's work and all those sorts of things. So I mentioned the upstreaming effort. I suppose the other two, the hardware things which will be coming up in the near future, are the camera module, which you'll probably see next month, which is that's a 5 megapixel camera, supports using our GPU. We can do real-time H.264 encode at 1080p. And at some point there'll be a display adapter which uses our DSI connector. We should support LVDS displays. I perhaps should mention two particularly successful community projects here. The Raspberry Jam community has, so basically it's very much like a Linux user group. You have somebody decides that they like to have a Raspberry Pi meetup in their area, they set it up, people come along, they share their experiences, people who are newbies, people who are experts, and we've had them all over the world now. We've also had a fully community-written magazine called The Magpie, which has sort of articles, ideas on projects, information about getting started. Now, if you're wanting to help, if you're just getting started and you're having problems, then definitely looking at the forums is particularly useful. Or if you're just getting started and you want to help other people out, again, very, very useful. Generally, if you're a software developer, hacking, doing cool stuff, sharing it, explaining how you did it. If you're particularly keen, then hacking on the core software platform would be amazing. Also, these Coder Dojos, Code Clubs, or whatever the equivalent you currently have here in Australia, they seem to have been pretty successful so far in the UK, and it's a good way for you to, I think it seems to be a very rewarding experience to go into schools and try and teach children some basics of programming. And if you're somebody who has a particularly generous employer, or think you may be able to help or be interested to talk to me, then please talk to me afterwards. And yes, I think I will take questions now. I should mention I'm in Melbourne and Sydney next week if other people have events going on there they want to tell me about. And I have a bonus link to using Raspberry Pi as an FM transmitter, which is very naughty and you should be very careful, as it's not very cool to tread all over the FM spectrum, but you can just hook up a wire to your GPIO pin, and using the code they've done, you can get pretty workable FM radio transmission.
Thanks very much, Brett. We have time for a couple of questions, so hands up, there's one.
I've got a 5-year-old son. How do I get him started with Scratch? Like, I've had a little 2-second play with it and it doesn't look that obvious. I want to kind of, is there some tutorials or something like that on the web that we can, in a project to kind of follow along?
Yes, loads of them. So MIT have done fantastic work on producing a community for Scratch. So they have all sorts of example projects, tutorials, manuals. Also, the UK-based Computing at School group, they have a Raspberry Pi educational manual which has a chapter dedicated to Scratch, which should give you a walkthrough to get you going. And once you've picked up the basic principles, you'll find it quite straightforward.
Is there any thought to a new version, and are you going to call it Pi Squared?
I have no comments on future versions of Raspberry Pi which may or may not appear. Some of you may be familiar with the Osborne effect, the story of the Osborne Computer Corporation pre-announcing a new product. As I hope that I've described here, we're focusing very heavily on supporting, improving, optimizing our current platform. We're very happy with how it is.
I've got one up the back.
What do you think the effect of the Raspberry Pi competitors will be on your charity's goals? So the QB board and some of the other ARM clone boards that are coming out?
Yeah. Well, as long as if the competitors are low cost, they're well produced and they're available in quantity, then it's all good as far as we're concerned. If the Raspberry Pi was produced in order to meet a need, which was the lack of this hardware being available, I think that many of the competitors have had trouble getting substantial quantities available. They don't have the same user community we have right now, so there are definitely advantages to Raspberry Pi as it stands. But if someone comes along and does it substantially better and it's still an easy-to-use platform which anybody can program for, it's all good.
Okay, that's been a fantastic presentation, and thanks very much, Brett. And from LCA 2013, a blanket to take home to cold old England.